Hello, everyone. Are you ready for our next speaker? I'm Lizzie. I'm a developer evangelist at Twilio, and you should put your headphones on to get ready for our next speaker, Maya Berhovska.
So hi, my name is Maya, and I'm a software engineer at Airbnb, and I have a bit of a confession to make. Even though my company is a Ruby on Rails shop, and we have tons of Java services, I've managed to get away with writing exclusively JavaScript for going on 4 years now. I rarely touch the API. I never get entangled in the world of state management or, bootstrapping data. I work strictly in the presentational layer, which I've been told is a bit unusual at this conference. So maybe I can get a better sense of your experience by a show of hands. How many of you are strictly back-end engineers in your day-to-day? All right, a few. How many of you consider yourself full-stack engineers? Bigger chunk. And how many of you are front-end engineers only? Okay, we got a few. And how many of you, especially those front-end engineers, consider yourselves to be React experts? Yeah. So for the few of you at the top of that stack, this talk may seem a bit rudimentary. I think it'll still be useful, but we are going to go back to the basics and really think about the foundation of React and how we can leverage it to build beautiful, fast experiences. So what we're going to cover today is we'll first establish specifically the type of performance we're focusing on. Then we'll introduce React and talk a little bit about what made it special and unusual when it first came out. And finally, we'll use a case study to think about what challenges exist in more complex features and applications. So, performance. I imagine many of you have worked on performance, either by building really robust APIs, optimizing databases. I don't really know what backend engineers do, to be honest. But what I'm talking about here is performance in the browser. So a large focus of that kind of work today is actually on the initial page load time. There's a ton of different metrics that people look at. There's time to first interactive, time to consistently interactive. This is TTI, probably the biggest one in use right now. But we also have first paint, first contentful paint, first meaningful paint. These are all actually different. And even hero rendering times. And so all of these metrics are very important because as an industry, we're actually getting worse at them. Many surveys have been done on TTI and modern websites. And a recent one looked at travel sites, maybe Airbnb.com is an example, and travel sites had a median TTI of 4.1 seconds. And only a quarter of them made it under the 3-second mark, which, users are fickle and impatient. As a user, I'm fickle and impatient. And so I have to be incredibly dedicated in order to visit a website and wait 4 whole seconds for the content to load. So why is this happening? I'm going to let you in on a little bit of an industry secret. We're writing too much JavaScript. There it is. I never thought I'd say it, but it's out there. We're writing too much JavaScript. But why? Well, the answer is, of course, that there's a tender balance between loading performance and writing less JavaScript to get that sweet loading performance and having a developer experience that isn't truly awful. JavaScript is like the Wild West. It literally lets you do anything, often without error, sometimes with super unexpected results. And so especially in a cross-browser, cross-device world, we need frameworks and libraries to help abstract away the horror and chaos and to make development more robust for the web. So, in particular, when React came onto the scene, it was cutting edge in how it helped developers handle performance at runtime. So in this talk, we're going to forget about loading performance and assume that you've already bought into the hell that is hundreds of JavaScript libraries. And we're going to focus on performance at runtime, which we refer to as render performance. So generally, I would describe that as everything that happens after the initial page load. And we can think about it more specifically in answering the question, why? Why focus on render performance? Well, Paul Lewis, a great web performance engineer at Google, talks about how users of today's web expect that the pages they visit will be interactive and smooth. Pages should run well, scrolling should be stick-to-finger fast, and animations and interactions should be silky smooth. A lot of this comes from the expectations that we've built for users with the wonder that is native apps. And now we have to match that smooth native experience in the browser, on desktop, on slow devices, on old devices, and on terrible connections. So let's dive into React, talk about what it offers us in this sphere, and why that was different from how we'd been building websites before. In a traditional front-end world, we were writing HTML, CSS, and JavaScript as separate entities that would sometimes interact with each other. This was the world powered by jQuery. This was the model on which Backbone flourished. This was the general idea behind Angular 1. You would have your DOM structure determined by an HTML page, maybe some templating language that will allow you to do for loops and interpolate variables. And you'd ship all of the CSS you would ever need in one style sheet at the beginning. And your JavaScript would handle user interactions and re-rendering the entire page whenever anything changed. So React came onto the scene and had a lot of hype. People were very excited about React. But this was also the time where you weren't a real front-end engineer until you had built your own framework. So people, it's OK to be cautious. React was really just a sea in a lot of different frameworks. We'd just gotten over CoffeeScript. Here was something totally different how we were supposed to build things. But the reality was that it wasn't just another millennial trend. React actually introduced something different. Whereas before, in a world of HTML, CSS, and JavaScript, as separate entities, we'd have full pages as the mental model of the web. React introduced a new way of thinking. Pages became components, and components were composed of smaller components, which were composed of smaller components, and even smaller components, and so forth. Each React component was modular by default and encapsulated a view, controller, sometimes even styles. And what this gave us was a detangling of much of the web. So in short, what that really means is that instead of a classic MVC-like model, React is module-based. And all of that controller logic, DOM structure, data models can be self-contained in an individual piece. At Airbnb, we even put the styles encapsulated in each React component. And so layers in this tree are contractually separated via props and prop types. And that's short for properties and something we'll dive into very deeply. And React, most importantly, uses a virtual DOM to identify what has changed on the page and then only repaint what it has to. This was super unique when React came out and a big change in how we were building websites. This is what we're going to be focusing on today, and this is what we're going to leverage to build some much more performant applications. One last thing I want to talk about is the React component tree. We'll be coming back to this a lot throughout kind of our building of simple components. And so it's important to consider this new mental model of the web. We have our root node application, which renders, again, those higher level components and goes all the way down to the dumbest thing on the page. A piece of text may also be an individual component. And that's the way we think about React. So what's a component? This is a really important question, since I think I just mentioned that word like 100 times. Well, it's actually very simple. For the most part, a component is just a function. It takes in props, properties, and state, and it spits out DOM elements. We'll dive into a very simple example right now to understand the difference between props and state and how we might use them to build an actual component. So when I think simple, I think calendars. How many of you have worked with dates and times before and found it to be easy? Exactly. But in this case, I think this will be a nice precursor to the more complex example we'll explore at the end of this talk. So we'll build a very, very simple calendar. When I first receive a design like this, I try to look at the simplest pieces first, especially if they repeat and therefore are clearly reusable, and define those as components first. So in this case, it's going to be the individual days on that calendar. We can see that all of these squares are basically the same, and that there are two features that may change. First is the number that's displayed, and second is the styles that are then applied. So we can map those two features to our props. I start almost every component, no matter how simple or how complex, with defining the props based on those features that we may swap between components. In our case, the day is going to be a number. And because we just have really those two modal states, whether the day is selected or not, I'm going to have a Boolean prop called isSelected. You can imagine we could get really specific with the types. We could also get really fancy with the allowing more customization. But I think this is enough for now. Once we have the prop types defined, we can take a look at the component itself. Again, component is just a function. In this case, literally. We'll call it a calendar day. And the only argument it'll take in is a props object, whose contents we've determined by our prop types definition. We can destructure that object and grab the day and isSelected prop. The day prop is easy. We'll just render that number directly onto the screen in a div. And we'll use the isSelected prop to modify a class name. We'll have a default style, and in the isSelected case, we'll append another selected style on top of it. Again, there's a lot of details in this and a lot of decisions I've made. I'm using class names here. You could use inline styles. You could use a library. But the basic premise is always going to be the same. And we've referred to this kind of component as a stateless functional component, or an SFC for short. The most important feature is that kind of obviously it has no internal state. It's a product of its props, returns DOM nodes. It has none of the fanciness that you may associate with React components. If you've seen them, no lifecycle methods, no instance methods, no constructor. It's a bare bones JavaScript function, just like any other. And as a result, it's the most performant type of component. So you should use SFCs wherever possible. And generally, it's mostly visible when we think about that mental model of the React component tree in the leaf nodes. Although again, very performant, I recommend using SFCs wherever you can. Now, our next step here is to go one layer up and build that wrapping container that will render all of the calendar days in our month. We'll call this a calendar month component. And in this case, it needs to know which day is currently selected. So we don't want to use an SFC because we think we're going to store that in internal state. As a result, we'll extend React.component. And this will give us a lot of exciting things. But the biggest one for us is it'll give us state. And that state will update our function automatically. The only required method on a React component is the render method. This is very similar to an SFC. It has access to the props. It has access to the state as well. And it just returns a DOM node. So in this case, we're going to return a table. It's going to have a caption of October. I'm really simplifying this. Nothing is customizable. Everything is hard-coded in. So we can forget about time zones and all that jazz. And so then I have abstracted away the magic of the actual weeks in the month. So we can assume we'll get a two-dimensional array that returns those numbers in the appropriate place. We'll map over it and render each row. And then we'll map over each week and render each calendar day. And again, we'll just pass in that day as a prop. That's the syntax for that you can see right there. For the selection, we'll go to our constructor and initialize the state. So in this case, because it's today, we're all here for Signal. It's very exciting. We're going to initialize the state to have a selected date of 17. And then we can access that in our render method and set the Boolean prop appropriately. There's a lot more, obviously, that can be done here. We could update the selected date on click and all of that stuff. But this actually gives us all of our spec for now. And that component, again, is called the Stateful React component. It extends the React.component class. It inherits all of the updating based on state, not just on props, as well as component lifecycle methods. It allows for defining instance methods on the class and generally more complex logic. And as a result, you'll see it closer to the root node of your application, your libraries. That's generally when you'll have more stateful React components. And voila, we have built everything we need for this particular design. So in this section, we introduced SFCs and stateful React components. So it's kind of, we can compare the two to talk about where we would use each one in each case. But realistically, the comparison is, do you need state or not? And if you don't, in most cases, you should use an SFC. So it's worth talking about props versus state, rather than SFCs versus stateful React components. In this case, both of these objects, keys that you define completely up to you as the developer, and they both are used to influence what is rendered on the screen. Very simple. And changes to either of the keys within these objects will automatically re-render the component. That's React's thing. When you change the props, when you change the state, you get a re-render. The main difference is props are exclusively controlled by the parent component, whereas a parent has no knowledge of the internal state of stateful React component. The corresponding thing here is that you will never be able to directly change the props on a component within the component itself. It may happen through a callback passed up the tree, whereas the state, there's actually a set state method that lets you change those things. And so the difference in how you instantiate this is with props, they're enforced via prop types on the component. That was that first step we took, whereas the state is going to be defined in the constructor. And that's kind of the main difference. So you'll assess whether you need eternal state when you're using these two tools. So let's look at a more real-life example of a calendar. Obviously, the kind of calendar we just built is not entirely realistic. It does not allow for selection. It doesn't allow you to navigate to different months. There's no ability to block certain dates. This layout isn't responsive, and there's no real customization to speak of. At Airbnb, we needed a calendar component that did all of those things and more, and could even be adapted for future use cases that we didn't yet know about. So the end result is a library composed of many, many, many layers, like very many layers. And as a result, many opportunities for good and bad choices in prop and state design that would affect the render performance of the component. You can see here, we do still have a calendar day component and a calendar month component, but they're also grouped with input components, as well as these controllers that allow you to select various ranges and show and hide the calendar, and like all sorts of stuff going on. So again, more components is more opportunities for disaster. What we'll talk about today is one specific feature of the React Dates library, and that's custom day styles. We have these keys kind of saved within the component, things like selected, hovered, highlighted today. And each of these keys map to individual class names on the calendar day component that then map to individual styles that can be used to modify each day in whatever way you would like. So we'll go into how I first built this before I knew a lot about React, and all of the various stages about how it can be improved to where it is today, essentially. This is closer to reality. It's not quite the same. It's still a bit simplified, but we'll get a good sense of how complicated React can actually get. So because these custom day styles are related to stateful things like date selection, hovered state, it makes sense that they belong in our top-level root node component, the date range picker. We want our state near the top of our component tree. The date range picker renders a day picker, which is essentially that calendar dropdown that we saw in the GIF. And in the first iteration, we'll pass in a day styles object. And this object will essentially take those individual keys and map them to functions that'll return true or false depending on whether the day in question should have that key. So for instance, for today, October 17th, the first function would return true. The next two, probably not, unless there was a different situation. But this implementation seems great, does what we want. We can imagine these functions will get passed all the way down to the bottom of the tree, where the calendar day could use them to apply those class names. But it's actually deeply problematic. And the reason why is that tricky second curly brace. So thank you, JavaScript. This is actually creating a brand new object on every render, which means on every render, we are passing a brand new shiny prop down to the next layer in the tree and the layer after that. And every single one of the 30 or 60 or however many months of days we're displaying is getting a brand new object, and we're re-rendering every single piece of the calendar, even if we didn't want to, even if nothing changed. So how do we improve this? Probably the easiest thing to do now is we had this daystyles object because we thought that people would modify the layers below the tree to add new styles. We were seeing that that didn't really happen. So why not just hard code them in as functions? In this case, we can control every one of those custom daystyles. We'll have a callback for it. And this will only get updated when that function changes. But this, too, is deeply problematic. Thanks, JavaScript. Arrow functions, while they may give us the right context, are also instantiating a brand new shiny function every time you write that code, which means now instead of passing in one shiny new prop that goes all the way down the tree and updates every component, regardless of whether we wanted that or not, now we have at least 3, but I think we have like 10 of these styles right now. And every time we're doing unnecessary updates. So the easy thing to do is let's set those functions to be instance methods on the class. Now they're only instantiated when you instantiate the component, and they'll never change between renders. But now we're in a sort of situation where that's never going to update, because we're never changing those functions, regardless of whether the return values change. But if we go back to what we had before, we're going to be updating all the time. And both of these scenarios are bad. We're in an impossible situation. What do we do? Well, I'm here to tell you that this is a false choice. This isn't a cop-out answer, but realistically, the architecture we designed is not that great. We want the calendar day component to be a stateless functional component, but we've somehow created this implicit state where it has to use these functions that we're passing all the way down the tree in order to determine the class names that it's rendering, and that's really bad. So cancel that architecture. We can do better. What if we just pass down only the keys that the calendar day was going to use? So here's our new approach. Back in our date range picker, at the top level node, let's actually define a state that maps to those custom styles. We'll call it day styles. We'll instantiate this object only in the constructor, so we're not doing anything messy. And we'll have a key for each month that we're rendering. So we'll have one in the ISO format for October that'll map to an object. In that object, we'll have a key for each date that's visible. And then we can pass in an array or a set of all the different keys that we want to actually be applied to that day. Then in our render method, all we do is pass down that object that we took from the state. We're not doing any creation of new objects or new functions here. It's been set once in the state, and the date range picker will update it as needed. Then going down the tree, once we get to the calendar month, we can hack apart that day styles object and present the calendar month with only the information that's relevant to it. And going even further, we can give the calendar day only that array that it needs. And that's really great. That's much better than any of the architectures we built before. And then if we want to update that, like if we were to click on a date, then what we would do is grab that day styles object from state, copy it over using the set state method, you can see those curly braces. We're creating a new object, so it'll force an update. That ... syntax is fancy ES6 for copy over all the contents. And then for the month in question, because we're passing back the day, what we can do is create a new object for that month. So if we were rendering October and November, we only re-render October. And then one step further, we copy over all the contents of that month and only update the object for that day in question. And this allows us to, on click, skip over every other day because they haven't changed, and only update today to have the styles that we need. So the TLDR of this deep dive is that you need to be especially careful when using objects, functions, and arrays as part of your props and state design. You can use them to great effect, much like we did in our updated architecture for the library, but you have to be thoughtful about it from the beginning, because you can also very easily cause endless re-renders unnecessarily. So some guidelines for better component design going into the wonderful world of React for many of you. Use stateless functional components until you can't, literally wherever possible. Only change it if you need that instance method or that state. Default your prop types to Boolean, strings, numbers wherever possible. A lot of the times we're getting JSON API responses and dumping that straight into the component. But that's not always the best answer. It's good to separate it out into these very primitive prop types. And when you do use functions, cache them by declaring them on the class instead of declaring them in each render methods. And same for objects and arrays. You can save them in state and then only update them on an as-needed basis. In summary, these guidelines may seem simple, but they'll actually get you a pretty long way towards building a great React experience for your users on the web. So thank you. If you want to help me out and deep dive into more tricky date picker related performance queries, you can check out the React Dates library. It's under the Airbnb namespace on GitHub. And of course, you can tweet any questions you may have at me. I'm always open to chatting. Thank you.
Thank you, Maya. Now we have some time for Q&A. I can run the microphone around. OK.
Cool.
You're first.
Yeah, I was just curious if you know if it's possible to use Redux with the stateless. I'm sorry, the stateless components and just the props.
I think Redux generally, like, it's holding state in context and then you're passing it in as props to a component. So it definitely works with SFCs. You just connect them in the export, I think.
So you refactored that piece a bit. With the expressions that you had in there in the render method, did those fire continuously in the DOM for React, or are those only called upon render themselves?
Sorry, yes, so they're only called when the parent updates it. But so this was a small piece of what's happening in the React Dates world. So what ended up as a result of those functions being created on every render was like, if anything else changed, even if it had to do with like the navigation or with like the show and hide state or anything like that, it would just trigger a giant tree of re-renders, and it was very, very slow, especially on mobile devices.
Anyone else?
First question ever. I'm wondering about whether accessibility has been solved for React.
Accessibility, I don't know the role that React plays, because a big part of it is like you need to be considering semantic web elements. So it's the DOM elements that you pick, the ARIA labels that you apply, and you're using the tools of HTML in React, and the tools of HTML are the best ones to help with accessibility. So I don't know. I don't think accessibility has been solved for the web. There's still a ton of components where we're designing the specs for. Sliders in particular are very challenging. Calendars are very challenging to work with both screen readers and keyboard users. So I think that React is a tool, and you can build accessible components using it. But I don't think it hinders or helps in any way. It's on the developer.
Hello. What I have two questions. What would make like week worthy of its own component, and do you plan to support time, like time selection and stuff like that? Because I was going to use your library, but I didn't
Sorry.
have time to implement time.
Yep. Yeah, so right now, time in particular is not on our roadmap. It's not a big use case for Airbnb, and the trickiness surrounding even like range selection is a lot for just me. Give me some slack. As for creating your own component for Week, so we considered it, but the only real reason it made sense for us was for prop types validation, and I think that there was a performance case where we could only re-render the week instead of the entire month. And that was a bit better when we were looking at the tree, but I think it's like a case-by-case basis. There's not a lot of content, it just renders a TR. I think it's a good barrier to that re-rendering, and it's also a good barrier for like enforcing certain prop types validations. But depends.
Thank you.
Yeah, we got it. Cool. In the back. I don't know that that mic is actually on because I guess I should have headphones on.
I was just wondering if you had any advice for related to, so time goes on from the beginning of time to the end of time. And I know I've built a bunch of stuff where there's really, really long lists of DOM elements and sort of trying to find out exactly where you should draw the line in terms of what you should render, what you should just leave somewhere else.
Yeah, this is a big question that we've had, mainly because we keep having designers who want to map the native app experience for the calendar precisely and have infinite scrolling, which I do not recommend. Infinite scrolling is a great anti-pattern. It's terrible for accessibility reasons. But so there's a lot to be said going back to like the loading performance conversation for only rendering what's above the fold and then lazy loading everything else on kind of an as needed or after the everything is interacted method. So in general, you don't need to render everything that will be on a page in the first go. And if you paginate, that's usually a better experience for all users, keyboard users, screen reader users, and so forth. And that helps solve a little bit of the challenge. Does that answer your question? Cool.
Any more questions? Okay.
I'll be over here.
Another round of applause for Maya, please. Whew.
Thank you so much.